All right, good afternoon, everyone. My name is Kalyan Gunda. I'm Chief Architect for Unstructured Storage in Dell. We have Ugur.
Hi, everyone. I'm also from Dell, working at the CTO office as a storage technologist.
Yeah, today we are going to talk about object. Object not in the sense of object programming, right? But object, on-prem object storage, a little bit on its evolution and how various object features are mapped to different workloads, especially AI workloads, and end with what we think is a general object, on-prem object appliance architecture. With that, we get started, and object has been there for a decade or so now, or a little bit more than a decade. And over the time, object has evolved in various ways, mainly focused from cloud perspective, and then moving into on-prem, right? So before we delve into object, I kind of wanted to see how object is changing the on-prem infrastructure, and what does it mean for on-prem appliances. If you typically look at an application developer and he wants to start accessing storage in the data center, he would have to, let's say I want to write an application, I want to go create a storage. Where do I go? I need to go create a block volume or a logical volume, or I go create a file system. Can I do it? No, I would have to go and talk to the storage administrator to provision that storage. Now I write my application, and I want to access my storage, my file system, my logical volume. Let's take an example of file system and NFS, right? If I want to go run on a particular client, I can't do it because I need to go talk to the admin of that box to mount my NFS file system, right? That's been the traditional on-prem data infrastructure, right? And that's, that kind of puts the onus on a lot of dependencies for the applications into the storage administrator. Further, if I want to control the life cycle of the data that I have created in terms of how long it lasts, where does it stay local to the machine, does it need to be backed up, HSTR'd out, or replicated, right? Or even encrypted, right? If I want an application, I don't want to encrypt it, but I want my storage to encrypt it. But you encrypt it at each application level. The flexibilities are very limited in a traditional thing. Of course, some of these are changing and evolving even in block and file with advent of Kubernetes and stuff, but that's an evolution. Now, transform that into a simple diagram and say, if I'm an application developer, for me to do anything with storage, I have to depend on the storage administrator. The storage administrator further doesn't have an easy way to manage storage because these are all dependent on each vendor, meaning there is no vendor neutral API that says, go provision my storage in this way, go back up my data in the storage to set up replication or lifecycle policies and so on. So in some sense, I'm dependent as an application developer with the storage administrator and the infrastructure admin. And that admin doesn't have a unique way to manage my storage, meaning they're all vendor dependent. So keep that at the back of your mind and say, hey, these are the problems that we have on how we deal with on-prem data center. Bring object. Object has evolved, right? Object is nothing but an immutable set of data. And it can scale well in terms of billions and millions and billions of stuff. And it is accessed over REST protocol, over HTTP. And since this has, object has grown into popularity via AWS S3 in the cloud, some of those aspects in terms of managing storage has moved up into the applications. I mean, now as an application, I can go access my object storage from anywhere, right? I don't need any storage infrastructure in terms of managing that, right? I don't need a mount point, for example, right? I can control how to encrypt my data on the server side with a particular encryption key per application. I can actually have a control on how my data is replicated, and it has a robust or extended infrastructure for metadata. If you think of metadata, user-controlled metadata, it's very similar to extended attributes in file, but a little bit more robust in terms of flexibility and scalability aspects of it. Lastly, as we all know, object is immutable by nature, which means it's not meant for every workload. It's mainly meant for workloads where the objects don't change that often, right? It's not meant for transactional workloads. So these are not, these are, I would just say, some of the things that catches our eye at a first look for object storage. There's much more to that. Now, talking about our problem and taking this to the next stage of saying what happens because of object in the traditional on-prem data center. Now, lot of foothold of storage was with storage admin. Now with application having the ability to actually manage storage in a completely different way opens up flexibility for applications, but a challenges from storage admin perspective. And hence, that's a journey that is happening in the on-prem data center, I would say, right? But the essence of it is the earlier problems with file and block where you are dependent on the storage admin are no longer there, and the storage admin has a pretty standard way of dealing with storage because the applications can now control their replication with a standard S3 API, right? The lifecycle policies or any of those aspects are all managed easily with a standard API across all vendors. Of course, we just heard how challenging it is for the S3 API to be standard, right? How it's not so compliant and how things change. While that is true, this is also true to some large extent. So a little bit on saying, object storage has evolved traditionally since it's immutable, it was mainly meant for backup and archive or videos and stuff like that, right? Images and so on. And over the time, it has evolved to different set of workloads, which is all the emerging modern workloads like AI, ML, data analytics, data warehousing, and real-time streaming of data too. If we'll take a look at this further with the object ecosystem, you can see that even in the backup archive, there are traditional players that has been backing up all kinds of data like databases, file systems, and so on. With the new workloads, now we have something like, if you say vector DBs, there are applications now you need to back up the vector DBs. And we talked earlier in the morning that one of the last phases of even AI is archiving. And that also needs to be considered for backup and archiving, right, into the object storage. And if you look at AI training and inferencing, which we are going to talk in a little bit more detail, there are various applications like PyTorch, TensorFlow, and so on that has played in a row. And different semantics and different needs are there in AI, which we'll talk a little bit more. Then if you look at data warehousing or data analytics, there's various ecosystems that have evolved in there. And the same goes with operational recovery and HPC areas where different applications have come in with slightly different needs grown into the object ecosystem. With that, we move to what is AI use cases and how different features are mapping to the different stages of the AI. Or you want to take the stage?
So let's talk about very high level how this the AI pipeline looks like. I know you saw this similar image earlier in the keynotes. But one thing I want to emphasize here is the AI is not just one workload, right? As you see here, it's a pipeline, and there are different stages here. And each stage has their own unique access pattern, requirement, characteristic, and there's no one good solution for all, right? And in here, if you look at this pipeline, we have the data ingestion, data preparation. These are well-known, let's say, object use cases and archive. But the training and inference, right, initially used to use file system as a storage. Now we are seeing also object storage becoming used for training and inference. And these two stages actually driving a lot of innovation on the object ecosystem and object storage solutions. So if you want to little bit dive and try to look at from storage perspective what's happening, right? The first stage is your data ingestion. You collect structured or unstructured data from different resources. Imagine this is I don't know, social media feeds, medical images, logs, right? You collect these data, and then this data is fed into the data preparation phase where you do cleaning, you do some data discovery, label it, do some feature extraction, enrichment, right? And then what you do is, after this process, you create the data sets for training, and also it could be also for the inference as well, right? And then this data set's gonna be fed in either your training workloads or inference. So here, we are always talking about like the storage AI, like I/O. I want to write the data, I want to read the data, but there's also a lot of like data management features become critical, especially in the AI domain, right?
Yeah, I mean, if you think about this, right? What are the S3 features that are critical for these stages of the pipelines, right? One is, as we call pipelines, the whole intent of it is that something changes and that triggers an action by some other component, right? So the S3 notifications could be used for triggering the pipelines of when the data lands, I want to click, I want a Lambda function to be triggered, or some other function like, I want to clean up the data, right? As the new data is streamed, I want to do the data preparation for it, that can be triggered. And the same applies for across the pipelines on various stages. So you could, notifications plays a role there. And as the data is cleaned up and prepped, you want to tag the data in terms of remembering what that data is. Like, if you have a bunch of images, you can say, hey, this is an animal, right? This image represents an animal, right? And you tag that. And then as you clean up further and enrich the data, you could say, hey, this animal is a dog, and that you could use the metadata for that, right? So the user-driven metadata and tagging are typically used for these purposes. And further, as you go further to make it ready for training, you want to save multiple copies of this data as you are enriching the data with different parameters and so on. You would end up using versioning. And lastly, replication is also considered. Could be considered from here on all the other stages further to protect your data and keep multiple copies of this as it changes, right? Which would use something S3 style replication that would replicate as many copies as you'd like. Right.
Yeah, and I also want to mention one more thing. Still, like most of the data preparation tools are still like running on GPUs, right? Think about standard like Hadoop, Spark type of clusters. However, when we move to the training, the story changes, obviously, because now we are actually trying to feed very expensive GPU clusters, right? These are expensive. We don't want to keep those idle. And in the training phase, there's like two main operations happening. One of them is the data loader, where we load the training data to feed the GPUs. And the other one is the checkpointing, where we want to dump the model state as soon as possible to the storage, right? And in here, their requirements, obviously, one thing we know is the input data sets can be like in terabytes to petabyte. Like data sets are growing. Similarly, if you look at the model sizes today, they're like growing. Your checkpoint size is growing, right? You want to provide like a capacity for them. The high throughput is required because we want to move the data to the GPU or from the GPU to the storage as fast as possible. So this is actually a great use case for RDMA. Right. The other thing is other important feature here is like the tiering, right? You have a training data which sits on your tier 1, tier 2. Before your training happens, you want to move that data to the fastest tier, like the tier that is close to your GPU cluster. So there are like a couple S3 features I think should play an important role in checkpointing. One of them is the versioning, right? The models do a periodic checkpointing to make sure the model stays stored. And these checkpoints actually can be stored a long time because you want to make sure, you want to observe, for instance, how your model evolves, if there's like, is it converging or is it diverging, right? And some of the time these checkpoints can be like an IP, like companies want to store them permanently, right? So what is the locking mechanism? What is the retention policy, life cycle policy? These are becoming very, very critical for managing your checkpointing. And similarly, the versioning, right? You do like multiple checkpoints during the training, right? And S3 provides you a versioning feature. If you are using file, then as a data scientist, you yourself have to implement this versioning logic inside your training application, right? So there are like a lot of, I think, unique features that Object can provide for training and fine-tuning. And the next phase is the inference, right? Once you have the final models, then you want to deploy this model and provide some real-time real-time like use cases for the customer, right? Again, inferences it's running on GPUs, and inferences like there was a discussion this morning, emerging markets, and we see new use cases actually in the inference as well that utilize the storage. One unique thing about inference is very latency sensitive. So again, like RDMA is a good use case here. You wanna, for instance, bring your model as soon as possible to your inference cluster and make sure it's running. Another use cases we are seeing recently is the KV cache offloading. So this is like a niche use case, I believe. But what's happening is if you are doing inference, if you're running an inference model, which is like transformer-based, like large language model, what's happening is it generates some like computational, like temporary key and values vectors, right? And these vectors are stored in today's like GPU's memory, and you use these vectors to generate the next token, right? And what's happening is when your content window is become large, or if your user like come and then leave the session, come after a couple hours, then it's become challenging to keep those like intermediate data. So what we see recently is people or the framework starts offloading these like intermediate KV caches to the CPUs, and even to probably we're gonna see it in the storage. So this is a very new use case. We still don't know what are the requirements or how is this gonna storage play a role. The other use case, I believe, I know there's another talk by Microsoft next session about the rack use cases, right? Vector DBs are using also object as a tier 1 storage. So it has to still like if you are using object storage, it has to provide like very fast performance, so the data can be retrieved very fast from the vector DB. Here, similar to the other pipeline, obviously versioning, retention, notification, lifecycle, and metadata, all these like matters. And then final stage is the archival. We wanna like maintain, store these like models and older data sets.
Yeah, and since object evolved from backup and archive, it's a perfect place for storing large archive kind of data, right? And large objects plays a big role in terms of storing huge amounts of data.
One final thing I want to mention, okay, how these AI workloads drive the changes or innovation in the entire data path of the object storage, right? So if you look at the very like high level stack, right, you have the applications, your frameworks, and then those frameworks use some type of like connectors to access to the storage. And then under these connectors, you have your SDKs, libraries, and then you have the protocol layer and you have the storage system, right? So what we see here is now we are seeing both on cloud and on-prem is all flash high performance object storage, right? They're trying to eliminate a lot of overheads with are associated with object storage, and then they want to provide like predictable performance, right? However, like that's not enough, because if you look at actually application space, a lot of applications still expects you to have POSIX API, right? So we see also innovation there, like the plugins for applications, for instance, PyTorch S3 connector. Dynamo has an Excel for inference engine. We have Fuse-based file clients like Mountpoint, Cloud Storage Fuse, which converts those like POSIX calls to the object APIs, right? And then if you look at the SDKs, we see a lot of optimizations in the recent years. We have, I don't want to say recent, but new like common runtime libraries from AWS, a lot of optimization happening on the networking side, checksum authentication side, right? And then finally, more recently, we see also innovation on the protocol layer, right? Here is our RDMA. We also see new APIs are coming up.
Yeah, I think one could say that there is innovation across the stack focused on performance and simplification from access perspective, right? Removing the complexities of understanding of the underlying implementation into the libraries. Now, lastly, we want to kind of towards the end, want to talk about what is a typical on-prem object storage looks like, right? You have a storage subsystem, and you want to be able to provide failure protection against any of the storage infrastructure, which is disks, nodes, racks, cables, and switches, and so on, right? And then you have a bunch of metadata And the metadata is critical for the efficient scaling. And some aspects of object makes it simpler for the metadata to scale across nodes. And I would say, while typically we talk about scaling in terms of the nodes, but I would like to talk about both nodes and capacity, right? As objects are growing with a lot of data, so we are talking about exabytes of storage clusters, and how do you scale exabytes of storage clusters, both from a storage perspective and metadata perspective. And having efficient, scalable metadata has a direct impact on various S3 operations, right? Like listing would be one example. And then you have a S3 protocol handling or object handling, and then you have IAM and replication aspect of it. So the fundamental aspect of object is that it's immutable in nature, and which means that you don't have some of the problems that you would see in a typical file system, right? If you consider any POSIX file system, you have a file. The file can be modified from anything, right? That's the typical of the transactional workloads, that I have a big file, I have different people modifying, changing, and so on, right? Objects don't have that. So the nature of the objects of having a simplistic view of things in terms of data, of written once and read many times, allows the architecture of overall object system that is built based on object as the main criteria, has a very simplified architecture in terms of not needing elaborate distributed locking mechanisms to deal with your objects, which means you can evolve into a lockless architecture that allowing you to scale to exabytes of data or thousands of nodes of it, right? So this, and then further, because if you think about S3, it has started from eventual consistency and moving to strong consistency. So you have strong consistency in the data center, and then eventual consistency S3 provides across multiple of your replicas. And if you take about typical replication that you would do on a file system, it's based on the snapshot, it's a whole replication, and then how do you maintain consistency if you want to do active-active? It's a pretty complex architecture if you want to do a multi-site active-active kind of a thing, right? But S3 allows you to do that in terms of object, because it's write once, rather than S3, I would say object allows you to do that because it's immutable data, and if you have multiple replicas, any change on any one of the sites becomes a different version. So you don't need to maintain exact consistency at an object, because the object is immutable and hence consistent by nature. Any changes end up with different versions, and you have different versions of the data that are still consistent in nature. That allows us to do certain things like much flexible types of replication, much simpler in an on-prem appliance, right? And this kind of tends into saying that object allows you for the scalability and the flexibility in terms of various features, comes in and helps us to do well in an on-prem object storage system. So kind of stop here and look for any questions. No? Okay. All right, yeah, okay. I think I'll just I'll pass it on to you. Yeah, there's a question here. Okay, somebody here? All right.
Yeah, I was just curious if you could speak more to the multi-site architectures that you see, and I'm also curious if you see any hybrid deployments, cases where people may be using a combination of S3 in the cloud and Dell on-prem, like what those reference architectures or use cases would look like.
So in general, I would say that there are various use cases where people have been talking about hybrid, where applications are seamlessly moving between hyperscalers like S3 themselves, AWS, to on-prem. We do see customers doing that, if that helps. Let's do this.
Actually, I have the same question as Ryan's first question. I think you focus on the second one.
Okay. Yeah. I think we can hear.
So I had the same question as that Ryan's first question, which was really about the multi-site part, where specifically about AI, if you think about exabytes of data, these data volumes are huge. Moving them around is expensive. Can you elaborate a little bit on how that fits in? Because I agree with you, multi-site is a crucial aspect of object storage.
Yeah, in general, I mean, I would say slightly, it all really depends on what kind of failure protection you are looking at, right? And I would say, ignoring AI for a second, there are customers who would want, one replica, and there are customers who want multiple replicas. And the way I look at it is also that S3 allows you at a granular level of replication. So each application could decide that, hey, I want this one to be replicated to n sites and so on. I would generally say that we do see customers who are replicating across multiple sites, more than 2 for sure. So I think it's evolving, but you are absolutely right that when you think about exabytes of data, how does replication play a role? Would you really invest in multi-site exabyte infrastructure, right? So I think from my perspective, I see that a lot of customers might not actually replicate the whole exabyte, but they would be replicating the most critical data that is. That could be half exabyte or petabyte. I'm not sure. It depends on their use cases. So. Switch on. Yep.
Do you think that there's a trend in reducing the feature set for on-prem compared to cloud to focus on these workflows, or is there still a drive to maintain feature parity with like hyperscaler cloud applications?
I would say excellent question. It's a very simple but yet very good question. I would say there is a lot. There is a like we talked in the earlier presentation. What is S3 compliance mean, right? And I look at it as there is a, as we were going through that presentation and earlier too, saying there is a subset of the overall S3 API. I would consider this or like absolutely must for one set of applications. And then you move to the next set of applications. For example, I would give you saying, hey, for a long time, there are people using versioning. But then there are a lot of applications who don't understand versioning. They're just using it. And when they run into problems, then they realize that's because they're versioning. Or when they run out of storage, said, oh, I'm using versioning. I need to clean it up. I didn't know that. I thought somebody else would do. Oh, you need to set up a lifecycle policy. Is that supported, right? So I would say it's evolving from that angle and what is mandatory set of features. And it's evolving based on the workloads. So from that angle, we wanted to focus saying, in the AI use cases, we have seen that all these new set of features, though I wouldn't even call them new, but you will say versioning, for example. For a long time, the feature has been there both in on-prem and cloud, but I would say very less customers were actually using it well. Now we see that there are real use cases where people have started using it. And the other aspect is also the replication. It gives you the flexibility. And we are also seeing at least people also focusing on encrypting the data, having each application having their own encryption key, right? Rather than at a storage level or a volume level and so on. So that kind of flexibility is what we are seeing. Yeah, so I would paraphrase what you're saying that based on the workload, the subset changes. Yes, absolutely.
And just one other thing I just wanted to answer Thomas' question on the replication, right? I think one of the
Yeah, you want to use the mic?
mean, one of the things is really when you're doing inferencing on the robot side, for example. You're doing inferencing on the robot side and you collect the data. You want to keep it on the robot side for 30 days, but you want to move it to your data center. Or then you want to move it to the cloud. And that's where exactly the replication really kind of plays in role as well, where you do create your replication based on your metadata and you're moving it between different locations, or it could be across geolocations as well. So that would be one of the use cases to think about.
Yeah. Tiering and replication placed together and how you want to manage your data. I think someone else wanted? Yeah.
So my question is, what is more dominant in AI storage today? Is it file storage or object storage, and where it is headed to?
Yeah, very good question. Okay, there is a perspective. I would say it's my perspective. I don't know the reality because reality changes every day. I think traditionally, 6 months, a year ago, I would say a lot of it was file. But at the same time, if you're developing your AI applications in the S3 or any of the clouds, you end up developing as object. So I would say there is a much acceleration towards the object in the AI workload. So there's more adaption and more aspects of as you looked at different pipelines and different workloads, every aspect of it is adapting. And the reason for that is, while there are many reasons, one of the reasons is that some of the features of object aligns with those needs. Example of these flexibilities and versionings and so on. One of the critical ways is like if I'm doing a vector DB, for example, and I want to back it up. I can do it if I'm writing my vector DB. I could back it up and maintain versioning myself in my catalog. Or I could use the object versioning feature and do it, so which means I have less development to do. So each use case, based on that, some of the adaptation we are seeing much more increasing towards object.
Just remind people of that.
Oh, yeah, thank you. So with refreshments, just want to remind that we are actually doing a birds of feather session on AI and object, very similar to this. I would say that session is an extension of this session and more prone or more conducive to detailed discussion. And there is refreshments. So we'll all look forward to seeing you guys there. Sure.